Welcome back to my class in Advanced Statistics. Today we will take the second probability distribution for continuous random variable. It's called the exponential probability distribution. The probability density function associated with exponential probability distribution and the mean and the standard deviation for exponential probability distribution for continuous random variable are as follows. The probability density function for exponential probability distribution is given by f of x equals lambda times e to the minus lambda multiplied by x for x greater than equal to 0 and lambda greater than 0. This function e to the minus lambda x is the exponential function, where the base is the irrational number e and the exponent is negative lambda x, where x is greater than equal to 0 and lambda is greater than 0. The mean of the continuous random variable for the exponential probability distribution denoted by mu is 1 over lambda, and the standard deviation denoted by sigma for exponential probability distribution is also given by 1 over lambda. If you recall, in the Poisson probability distribution for discrete random variable, the discrete random variable x represents the number of events occurring in a given time interval, and the probability of this discrete random variable x, the number of events occurring in a given interval, is given by the Poisson probability distribution. Now, the time interval between the occurrence of two events is given by 1 over lambda, which is described by the exponential probability distribution. For instance, if we know that the number of patients arriving in an emergency of a hospital in 1 hour is 12 patients, and so 12 patients is your lambda. Again, suppose in a probability distribution, in a Poisson probability distribution, the number of patients arriving in an emergency of a hospital is 12 patients per hour. Then the time, the average time between the arrival of two patients is given by 1 over lambda, or 1 over 12 hour. And that's equal to 5 minutes. If we convert 1 over 12 hour to minutes, we multiply 1 over 12 hour by conversion factor 60 minutes over 1 hour because 1 hour is equal to 60 minutes. So 60 minutes over 1 hour is called the conversion factor, and 1 hour here will cancel out. You get 60 divided by 12 is 5 minutes. Again, the Poisson probability distribution gives the probability that the number of that the values of the discrete random variable x has, and the exponential probability distribution describes the time between the occurrence of two events. As in this example, the lambda here, which is one of the values of x, is the number of patients arriving in an emergency of a hospital, 12 patients per hour. And the probability of this, that x has this value, 12 patients per hour, is computed using the Poisson probability distribution. And the average time between the arrival of two patients in that emergency of the hospital is given by 1 over lambda, 1 over 12 hour or 5 minutes. And the probability that the time arrival between two patients in that emergency is 5 minutes is described by the exponential probability distribution. Now we graph the probability density function for exponential probability distribution for the first three values of lambda. Lambda equals 1, lambda equals 2, and lambda equals 3. If lambda is equal to 1, f of x equals 1 times e to the minus 1 times x. Or f of x equals lambda is 1 times e to the minus 1 times x. Or e to the minus x. X can have a value of 0 because the restriction on the values of x is x greater than equal to 0. So when x is 0, f of x or y is equal to 1. E to the minus 0 is e to the 0, e to the 0 is 1. If x is 1, the value of f of x or f of 1 is e to the minus 1, or that's 1 over e. If x is 0, the value of f of x or f of 0 is equal to 1. So the graph of this density function f of x will intersect the vertical axis at 1. If x is 2, f of x or f of 2 is equal to e to the minus 2 or 1 over e squared. So we observe that as x increases, as x becomes larger, the value of f of x becomes smaller. Because f of x is actually 1 over e to the power x. And this is the graph of the probability density function for exponential probability distribution when lambda is equal to 1. The graph intersects the vertical axis at 1 and the graph decreases and it's approaching the horizontal axis but never touching the horizontal axis, which means that the x-axis is the horizontal asymptote, is an asymptote for the graph of the probability density function for exponential probability distribution. Next, we take lambda equals 2. When lambda equals 2, the probability density function becomes f of x equals 2. Multiply by e to the minus lambda is 2 minus 2 multiplied by x. Again, the values of x are from 0 to positive infinity, which means that the graph of the probability density function is confined to the first quadrant of the Cartesian plane. When x is 0, you get e to the minus 2 times 0 is 0. E to the 0 is 1 multiplied by 2 is 2. Hence, when x equals 0, f of x or f of 2 is equal to 2. When x is 0, the value of f of x is 2, which means that the graph of this probability density function f of x equals 2 times e to the minus 2x will intersect the vertical axis at 2. And when x is 1, the value of f of x or f of 1 is 2 multiplied by e to the minus 2 when x is 1, or that's equal to 2 over e squared. And that's lower than 2. When x is 2, you get, when x is 2, the value of f of x or f of 2 is 2 multiplied by e to the minus 2 times 2, or 2 times e to the minus 4. Minus 2 times 2 is minus 4. Or that's 2 divided by e to the power 4. And that's even smaller than 2 over e to the power 2 when x is 1. So the graph of this probability density function will start from 2 and will decrease. And it will approach the x-axis but never intersecting the x-axis. And we call the x-axis the horizontal asymptote. Next, we take lambda equals 3. When lambda is equal to 3, the probability density function f of x becomes 3 multiplied by e to the minus 3 times x. Where x is greater than or equal to 0, which means the lowest value that x can take is 0. When x is 0, you get, when x is 0, the value of the value of the density function f of x or f of 0 is 3 multiplied by e to the minus 3 multiplied by 0. Minus 3 times 0 is 0. E to the 0 is 1 multiplied by 3 is 3. So when x is 0, f of x equals 3. When x is 0, for lambda equals 1, the value of f of x is 3. Which means that the graph of this probability density function f of x will intersect the vertical axis at this point 3 on the vertical axis. And when x is 1, you get f of 1 or f of x is 3 equals 3 times e to the minus 3 times 1. Minus 3 times 1 is minus 3. You get 3 times e to the minus 3, or that's equal to 3 over e to the power 3. When x is 1, f of x or f of 1 is 3 over e to the power 3. And that's less than 3 because 3 is divided by e to the power 3. When x is 2, you get the value of the probability density function f of x when x is 2 equals 3 times e to the minus 3 times 2 Minus 3 times 2 is minus 6, or 3 times e to the minus 6, or that's equal to 3 over e to the power 6. And that's even lower than 3 divided by e to the power 3 when x is 1. Which means that the graph of this probability density function from this point will continue to decrease. And it's approaching the horizontal axis but never touching the horizontal axis. And this is how the graph of the probability density function would look like for the first three values of lambda. For our example, for using the exponential probability distribution for continuous random variable, consider the following problem. The time in days between service calls on an office copying machine follows an exponential distribution with lambda equals 0.02. What is the probability that the time until the machine again requires service? A exceeds 60 days. B is less than 20 days. And C is between mu minus 2 sigma and mu plus 2 sigma. In this problem, there is a copying machine in an office, and the time between the calls for the repair or service requirement for the copying machine is 0.02 day. And the time between the service calls for the copying machine follows an exponential probability distribution. And we are asked to find the probability that the time in days before the copying machine requires another service or repair exceeds 60 days. And in letter B, we want to find the probability that the time before the copying machine requires another service or repair is less than 20 days. And in letter C, we want to find the probability that the time before the copying machine requires a call for service or repair is between mu minus 2 sigma and mu plus 2 sigma, where mu and sigma are the mean and standard deviation for the exponential random variable. But before we answer this problem, we take note of the following: the right-tail probabilities. We know from the discussion earlier that the graph of the probability density function f of x equals lambda times e to the minus lambda x for the exponential probability distribution would look like this. It will intersect the vertical axis at lambda, and the graph continues to decrease, approaching the x-axis but never touching the horizontal axis. Now suppose we want the probability that x is greater than or equal to a, and we locate a or x equals a in the horizontal axis, and the probability that x would be greater than or equal to a is the area bounded by this vertical line x equals a, and this part of the graph of the probability density function f of x, and this part of the horizontal axis. And this shaded part or the shaded region gives the probability that x, the value of the exponential random variable, is greater than or equal to a, and we will find this area using definite integration. Using a vertical rectangular element, we find the area of this shaded region that gives the probability that x is greater than or equal to a. If we use a vertical rectangular element, the area of this rectangle is length times width, where the width is dx. And the height or the length of this rectangle is the difference of the values of x at this point and the value of x at this point. At this point, this is a point on the graph of f of x. At this point, the value of x is given by f of x, which is lambda times e to the minus lambda x. Minus the value of x at this point, which is 0. So lambda times e to the minus lambda x minus 0 is lambda times e to the minus lambda x, and that is the height or the length of this rectangle. Now we want to find the area from a up to positive infinity. Therefore, the limits of our definite integral is from a to positive infinity. And we evaluate this definite integral. Lambda is a constant, so we can take it out of the integral sign. This now we equal to lambda take this out of the integral sign, we get lambda times the integral from a to positive infinity of e to the minus lambda x with respect to x. And to evaluate this definite integral, we make use of substitution. We let u equals minus lambda x. Integrate both sides. The left side with respect to u, derivative is 1, multiplied by du equals du. And differentiate the right hand side with respect to x, where lambda is a constant. Derivative of minus lambda x with respect to x is minus lambda multiplied by dx. And we solve for dx from this equation by dividing both sides by minus lambda. Minus lambda x minus lambda dx divided by minus lambda, we get dx. And we also divide the left hand side or du by minus lambda. This integral is now lambda times the integral from a to positive infinity. Integral of e to the minus lambda x is u. Multiply by dx minus du over lambda. And minus lambda over lambda will cancel out. And negative 1 is a constant. We take that out of the integral sign. Integral of eu with respect to u. And the integral of e to the power u with respect to u is e to the power u. Since this is a definite integral, we do not write anymore the constant of integration. We evaluate e to the u from a to positive infinity. And to evaluate e to the power u from a to positive infinity, we replace u with minus lambda x. And we evaluate e to the minus lambda x beginning from x equals positive infinity minus when x is equal to a. Now replace u with minus lambda x. So this becomes e to the minus lambda x to be evaluated from a to positive infinity. We start with x equals positive infinity. When x is positive infinity, we get e minus lambda times positive infinity. And you remember that positive infinity is a symbol. It is not a real number. It is a symbol that represents a very, very, very large positive real number. Minus when x equals a. When x equals a, this becomes e to the minus lambda times a. And we forgot there is a negative sign here. So this is negative times the integral of e to the u is negative times e to the u. So this should be negative e to the u. And we write negative here and negative here. This should be negative e to the u because there is a negative sign outside the integral sign. When x is positive infinity, you get negative e times negative e to the power minus lambda times positive infinity. Negative e to the power minus lambda times positive infinity minus when x is a. When x is a, you have minus e to the minus lambda times a, or minus e times e to the minus lambda a. And we simplify. If we remove the negative exponent here, applying the property of exponent, the first term is minus 1 over e to the power lambda times a very, very large positive real number. A positive infinity times lambda is positive infinity, is still very large and even larger than positive infinity because lambda is multiplied by positive infinity. So we can write the first term as minus 1 over e to positive infinity. This e to the power positive infinity is originally e to the power lambda times positive infinity. If you apply one of the properties of exponents to remove this negative exponent, you take this out, you bring it down to the denominator, it becomes minus 1 over e to the power lambda times positive infinity. But lambda times positive infinity is still a very large number. So we simply write positive infinity. Negative times negative is positive. And this should be negative. When x is a, you get minus e to the power minus lambda a. Minus e to the power minus lambda a. So the second term becomes negative times negative is positive plus e to the minus lambda a. And this is a very, very large number. If you raise e to a very, very large positive real number, the answer is a very large positive real number. And 1 over a very, very large positive real number is 0. So we get 0 plus e to the minus lambda a is simply e to the minus lambda a. And so this is the probability of that the value of the random variable x is greater than equal to a. It's equal to e to the minus lambda multiplied by a. For a greater than 0, as you can see in the graph, a is greater than 0. And this probability is represented by the shaded region, which is this shaded region is to the right of a. And that is why we call this right-tailed probability. And we will apply this right-tailed probability to find A, B, and C. The letter A of the problem, we find the probability that the time until the machine again requires service exceeds 60 days. In symbol, we want the probability that x greater than 60, where x is the number of days before the machine requires another service call or another call for a service or repair. In this probability x greater than 60, we take a equals 60 and we apply the right-tailed probability for exponential random variable. And it's given by e to the minus lambda a, where lambda is 0.02. So this is equal to e to the power minus lambda 0.02 multiplied by a, 60. And we compute this using our calculator. We have e to the power minus 0.02 multiplied by 60. And to two decimal places, you should get, we take four decimal places and we multiply it by 100%. To four decimal places, we get 0.3012. To four decimal places, we take the answer to four decimal places so that when we multiply it by 100%, our answer would be to two decimal places. To four decimal places, the answer should be 0.3012, and multiply that by 100%, you get 30.12%. That is the probability that the time before the copying machine requires another service call would exceed 60 days is 30.12% or 0.3012. Now we find the probability in letter B, the probability that the time before the copying machine requires another service call is less than 20 days. We know that the graph of the probability density function for exponential probability distribution looks like this. It will intersect the vertical axis. In our example, the graph will intersect the vertical axis at the point lambda equals 0.02, and from this point the graph continues to decrease approaching the x-axis. And the equation of this curve is given by the probability density function f of x equals lambda, where lambda is 0.02 multiplied by e to the minus lambda. Lambda is 0.02 multiplied by x. Now in letter B, we want the probability that the time before the copying machine requires another service is less than 20 days. And we locate 20 days in the horizontal axis or x-axis. Suppose this is 20 days, and the values of x that are less than 20 are to the left of x equals 20. Now to get the area of the shaded region, we get the probability that x is greater than or equal to 20, which is the area to the right of x equals 20. So we can apply the right tail probability for exponential random variable. And once we get this probability that x is greater than or equal to 20, we subtract it from 1. And we get the probability that x is less than 20. Because we know that the total area under the curve, all the total area under this curve with equation given by the probability density function is 1. So this area plus this area is equal to 1. And from 1 we subtract this area, the probability that x is greater than or equal to 20. Again, the probability that x is less than 20 is equal to the complement of 1 minus probability that x is greater than or equal to 20. And to find the probability that x is greater than or equal to 20, we'll apply this right tail probability where A is 20, and by right tail probability, probability of x greater than equal to 20 is equal to e to the minus lambda x, lambda A. The probability that x is greater than equal to A is, by right tail probability, is e to the minus lambda A, where A now is 20. And lambda is 0.02. And we substitute the values of lambda and A. We get 1. And we compute this direct in our calculator. 1 minus e to the minus 0.02 times 20. One minus e to the minus 0.02 multiplied by 20. And round this answer in your calculator to 4 decimal places. We get 0.3297. Thus, the probability that the machine that the time before the copying machine requires another service call or repair is less than 20 days is 0.3297 or 32.97%. 32.97% is the probability that the time before the copying machine requires another service or repair is less than 20 days. Now, we answer letter C that the probability that the time before the copying machine requires another service or repair is between mu minus 2 lambda and mu plus 2, mu minus 2 sigma, and mu plus 2 sigma, where mu is the mean equal to 1 over lambda, and sigma here is the standard deviation also equal to 1 over lambda, and lambda is given in the problem, it's equal to 0.02. Answer letter C that the probability that the time before the copying machine requires another repair or service is between mu minus 2 sigma and mu plus 2 sigma, where mu is the mean of the random variable x equals to 1 over lambda, and lambda is equal to 0.02, and sigma is the standard deviation for the random variable x, and sigma is equal to 1 over lambda, where lambda is 0.02. Mu equals sigma for the mean and standard deviation of the exponential random variable x, and both are equal to 1 over lambda, where lambda is 0.02. Lambda is 0.02. We calculate 1 over lambda or 1 over 0.02 using our calculator. We have 1 divided by 0.02. And we get 50. We can now compute the value of mu minus 2 sigma, where mu is 50, minus 2 multiplied by sigma is 50. And 50 minus 2 times 50 is 50 minus 100 equals negative 50. We also compute mu plus 2 sigma where mu is 50 plus 2 multiplied by sigma 50. And we get 50 plus 2 multiplied by 50 is 100 plus 50 is 150. Hence, the probability that the time before the copying machine requires another service or repair is between mu minus 2 sigma and mu plus 2 sigma, that is the exponential random variable x, is greater than equal to mu minus 2 sigma but less than equal to mu plus 2 sigma is equal to probability that x is greater than equal to negative 50 and less than equal to 150. And we locate these values of x, negative 50 and 150 in the diagram. Now, the values of x should be greater than equal to 0. And x represents time, therefore x cannot be negative. So the probability that x is greater than equal to negative 50 but less than equal to 150 is the same or is equal to probability that x is greater than equal to 0 but less than equal to 150. And this probability that x is greater than equal to 0 but less than equal to 150 is represented by the area of this shaded region. X is between 0 and 150. So what we will do is to get the area of this unshaded part, which gives the probability that x is greater than 50. And we obtain the area of this unshaded part using the right tail probability. The probability that x is greater than 50 is equal, as we have shown earlier, is equal to e to the negative lambda multiplied by a, where lambda is 0.02 and a is 150. And we know that the total area under this curve with equation given by this probability density function is equal to 1. Therefore, the area of this shaded part is equal to 1 minus the area of this unshaded part, which is the probability that x is greater than 50. And 1 minus the probability that x is greater than 50 by the right tail probability is equal to e to the minus lambda a, where a now is 50 and lambda is 0.02. And we compute the value of e to the minus 0.02 multiplied by 50 using our calculator, and we round off the answer to 4 decimal places so that when we multiply it by 100%, the final answer would be in 2 decimal places in percentage. We have e to the negative 0.02 multiplied by 50. Sorry, this should be 150. We want the probability that x is greater than 150. So A here is 150, not 50. The probability that x is between 0 and 150 is the same as the difference between 1 and the probability that x is greater than 150. And we obtain the probability that x is greater than 150 by writing probability, and it's equal to e to the minus lambda a, where a is 150. So this is 1 minus e to the negative 0.02 multiplied by 150. We calculate e to the minus 0.02 by, we calculate e to the negative 0.02 multiplied by 150 using our calculator. And to 4 decimal places, we get 0.0498. And we subtract 0.0498 from 1. We get 0.9502. Thus, the probability that the time before the copying machine requires another service or repair is between negative 50 and 150, which is equal to the probability that the time before the machine requires another service between 0 and 150 is equal to 0.9502, or 95.02% is the probability that the time before the machine requires another service or repair is between mu minus 2 sigma and mu plus 2 sigma, or between negative 50 and 150, which is equal to the probability that x between 0 and 150 is 0.9502 or 95.02%. For your practice, please try the following exercises. Number 1, a random variable x has probability distribution with density function given by f of x equals 1/4 times e to the minus x over 4 for x greater than equal to 0. Find letter A probability x equals 4, letter B probability x is less than equal to 1, C probability x is between 1.5 and 3, that is probability x is greater than equal to 1.5 but less than equal to 3, and letter D probability x is greater than equal to 1.5. Number 2 is an application of the exponential probability distribution. The useful life in years of microchip component within the coffee maker has an exponential distribution with lambda equals to 0.145. A. Find the expected value, that is the mean, and the standard deviation of the useful life of the microchip component within the coffee makers. Letter B. If it is decided to use a 5-year warranty, what is the probability or the percentage of coffee makers that the manufacturer can expect to be returned for microchip replacement under the warranty? The warranty is 5 years. So if a customer or a buyer of the coffee maker returns the coffee maker for microchip replacement for less than or equal to 5 years, then the microchip component will be replaced. And in letter B, you are asked to find the probability or the percentage of the copy makers that can be expected to be returned within a period of 5 years or less than 5 years, which covers the warranty of the coffee maker. Now, as an additional information, the probability density function for the normal probability distribution, which we have already taken in statistics 1, is given by f of x, and it's equal to 1 over sigma times the square root of 2 pi multiplied by e to the minus the square of the difference of x minus mu all over 2 times the square of sigma. For x is greater than or equal to negative infinity and less than equal to, this is greater than negative infinity, less than positive infinity. X cannot be equal to negative infinity or x cannot be equal to positive infinity because negative infinity and positive infinity are not real numbers, they are symbols. And this is the graph of the normal distribution. And we call this the normal curve, which is symmetric with respect to the vertical axis at 0. And the equation of this curve is given by this probability density function for normal probability distribution. And this is also the function that is used to generate all the areas under this normal curve, as summarized in the table for areas under the normal curve for normal probability distribution. And that completes our lesson for today. If you have questions about the exponential probability distribution, you ask your question in the comments below. Thank you for joining me in my class today in Advanced Statistics.